Jonathan and I did our case study on the hailstorm that hit Denver, Colorado on May 8th of 2017. The map on the right shows Colorado, and you can find Denver with a star next to it in the middle. This hailstorm was extremely devastating. There were over 200,000 people that were affected by this storm alone. The entire city of Denver was impacted, along with small suburban areas surrounding the city. Depending on where people were when the hail was worse, their car most likely received damage, not to mention the storm happened right in the middle of rush hour traffic. Mostly cars, along with some houses, were mainly affected. As you can see from the pictures below, roofs, houses, cars took the majority of the damage caused by the hail. There were about 150,000 automobile insurance claims filed and about 50,000 homeowners claims filed. This led to a total of about $1.4 million in damages. Denver is known to be an area hit with damaging hailstorms. This is due to their higher elevation and drier climate. In most regions, hail is able to melt before it hits the surface, but Denver has such a high elevation that the hail does not have enough time to melt. The drier climate also has an effect on the hail because there is little humidity, causing the downdrafts to be colder, resulting in hail. Also, due to the air in Denver being very thin, the hail will fall faster. Hail is a form of precipitation that is caused by the frozen water droplets. The frozen droplets fall within the clouds and then rise due to the wind and pressure, which causes other water droplets to attach and freeze onto the hail particle. This continues until the ice particle is too heavy and then falls to the ground. Hail tends to be round balls of ice that vary in shape and size. The water droplets are first able to freeze due to layers of the clouds being in high elevations. As we know from the lecture videos, as altitude increases, pressure decreases, causing the air to expand. This results in colder temperatures at higher elevations, leading to the freezing of water droplets into higher layers of clouds. Hail, just like rain, contributes to the hydrosphere cycle. Once hail reaches the surface, it will eventually melt and run off to nearby streams, which eventually reaches the ocean. The process of evaporation then takes place, contributing back into the atmospheric cycle that causes precipitation. Once melted, the hail directly interacts with the hydrosphere, contributing to the surface and groundwater. This is the 2017 Denver hailstorm. Thank you.